So before we start looking at reduced row echelon form today, just a quick review of row echelon form from our last lesson. When we want something in row echelon form, we need our diagonals to be ones, and then we need zeros in this bottom triangle piece. Once we get it into that row echelon form, we can do our back substitution. We start with the bottom row. Remember, these are your x's, your y's, and your z's. So the bottom row is telling me that z equals -3. Okay, so I have my first variable, and now I can do some back substituting. So now I go to my second row. We had 1y plus 1z equaling 9. And if we substitute that in, we have y plus a -3 equals 9. Adding the 3 over, we get y having to be 12. Okay, then we back substitute into our top equation. That said 1x plus 2y's minus 2z's equals -1. We substitute a -3 in for z and a 12 in for y. We have x plus 24 plus 6 equals -1. Combining like terms, we have x plus 30. Subtracting over, we get -31. So our solution, the point where all three of these lines would intersect, would be at -31, 12, -3. Okay? So last week we started talking about using those row operations to get it into row echelon form. Okay? I'm still going to have you do that on a couple of your homework questions today, but we are going to look at getting into reduced row echelon form, which basically takes what we have here, and instead of just getting zeros down here, we also have to get zeros up there. So all we have left is that diagonal of ones. Okay? All right, so what I want you to do for the first one, we need to turn this into an augmented matrix. All right, remember the augmented matrix. We start with all of the coefficients on the left side, and then we have that dotted line and our constants on the right side of it. Okay, so go ahead and convert that into an augmented matrix. All right, so our augmented matrix would be a 2, 1, 2, and 18. Second row would be 1, -1, 2, and 9. Third row is 1, 2, -1, and 6. Yes? Okay, go ahead and put that in your calculator. What size would that be? Yes, a 3 by 4. So go ahead and enter that in your calculator. All right, so if we want our calculator to help us solve this with an augmented matrix, we are going to go back to our matrix screen again. We've already edited it and we've entered our matrix. For the larger matrices, you might see this notation. It just means there are more numbers to the left. Okay, it's just not showing you the whole thing. All right, so go back into your matrix key. This time you are going to go over to math again. We've used that menu before when we found determinant. Okay, you need to scroll down and find those two. One says REF, row echelon form, and one says RREF, reduced row echelon form. I want you to do row echelon form first. Okay, so select REF, name your matrix, whatever you put it in as, and then hit enter. Okay, so you have to go and call up whatever the matrix name was. And when you hit enter, you probably see something like this. You may have more decimals than that. You can always change your mode to be 2 decimals instead of the floating. All right, that will round everything for you. Okay, so you can go under mode and change your decimals to 2. Okay. Now, in this format, our main diagonal, we have ones, right? And we have zeros in that lower triangle. So this is in row echelon form. That means we would have to do some back substituting to solve it. Okay? Now go back to your calculator and select reduced row echelon. Name your matrix again. And we should see that. So what they've done for us is they've done all of that the row operations that we did last week, all right, where they added rows together, they switched rows, they multiplied a row and added it to something else. They got it all the way down to where the main diagonal is 1, and everything else is a 0. Okay? And when it's in that form, we have all of our solutions right there. We have that 1z equals 3. We have that 1y equals 2 in our second row. And we have that an x equals 5. So there's no back substituting needed. Okay? All right, let's try another one with our calculator. So go ahead and set it up as an augmented matrix. Notice that this one has some variables missing, so watch for that. All right, go ahead and enter that in your calculator. All right, so we've entered our matrix in our calculator. We can call up that RREF option. Tell it what name you gave the matrix and your solution. All right, so again, this is our dotted line. We have our main diagonal of 1s. Everything else over here is a 0, which means the last column is going to give me all my variables. Okay, so I have 1w equals 1, 1x equals 3, 1y equals 0, and 1z equals -2. Okay. So for the larger matrices, we will use the calculator to do our RREF for us. Okay, but I do want you to still be able to get it into row echelon form by hand. Okay. All right, we're going to set up a couple word problems. Our first one, we are told the nutritional content per ounce of 3 foods is presented in the table on the right. If a meal consisting of 3 foods allows exactly 1,200 calories, 55 grams of protein, and 750 milligrams of vitamin C, how many ounces of each kind of food should be used? All right, now the one thing with this chart, typically when we were setting these up with our linear programming questions, we had our unknowns at the top. They have them on the side here. Okay? So they're asking us to figure out how much of food A, how much of food B, and how much of food C do we need. Okay? The totals, we want a meal that has 1,200 calories. We want it to have 55 grams of protein and 750 milligrams of vitamin C. Okay? So instead of having each row be an equation, when we had our unknowns on the top, since our unknowns are on the side, now each of these columns is going to give us an equation. Okay? So for an ounce of food A, we get 100 calories. For an ounce of food B, we get 500 calories. And for food C, we get 300. And we want a total of 1,200. So that's the first equation that I can set up. Okay? What equation would I set up for the protein? what can I write? 14a plus 15b, okay, 13c equals 55. All right, and the last one for vitamin C, we have 100a plus 550b plus 50c, and we want a total of 750. So we have a system of 3 equations and 3 variables. All right, we're going to set it up as an augmented matrix. So first row would be 100, 500, 300, and 1200. Our second row would be 14, 15, 13, and 55. And our last row would be 100, 550, 50, and 750. All right, go ahead and use your calculators. Get it into reduced row echelon form. All right, so we've got our matrix entered. We quit out of that. Go back into our matrix, over to math. We scroll down to RREF, and then we go back into our matrix, and oops, name it matrix A. All right, and based on the solution, the reduced row echelon matrix, what does it tell me? How much of each food do I need? This is A, this is B, this is C, right? So we need 1 ounce of food A, we need 1 ounce of food B, and we need 2 ounces of food C. Okay? All right, our next example. It says find the function f of x equaling ax cubed plus bx squared plus cx plus d, for which f of negative 3 gives us negative 84, f of negative 1 gives us 0, f of 1 gives us 4, and f of 2 gives us 6. Okay, so how many different equations are we going to have? We've got 1, 2, 3, 4 different scenarios. All right, so we're going to have 4 equations. We are going to substitute that negative 3 in for our x's, and we should get a negative 84 for an answer. Okay, so looking at our basic equation, we have a times x cubed plus b times x squared plus c times x plus d. Okay, and we are told that if we put in a negative 3 for our x, we should get negative 84. Okay, our second one. This time we are substituting a negative 1 for all our x's, and we are supposed to get 0 for an answer. Okay. We have 2 more to do. F of 1 equals 4. So if we plug 1's in for our x's, we should get 4 for an answer. And our last one says if we put 2's in, we should get 6 for an answer. Okay. Now, we have some simplifying we need to do because in this first column, all of those x's are getting cubed. In the second column, they're all getting squared, etc. So let's go ahead and rewrite this in its more simplified form. All right, so my first equation, what is negative 3 if I cube it? Negative 27. Okay, so we have negative 27a. What is negative 3 squared? So we have 9b. We've got a negative 3 times c. We're adding d, and we get negative 84. Okay. Our second one, we've got negative 1. What do we get when we cube negative 1? Okay, so negative 1a. Squaring negative 1 gets us 1. So we have 1b. We're taking negative 1 times c. We're adding d, and we're supposed to end up with 0. Okay. 1 cubed is 1. 1 squared is still 1. 1 times c plus a d, and we get 4. And our last one, what about 2 cubed? Okay, so we have 8a, 2 squared. So we have 4b. We have 2 times c. We're adding d, and we get 6. Okay, so that is the system that we are trying to solve. Can we turn that into an augmented matrix? And as I had said before, for these larger ones, we will let the calculator do all the work for us. We just have to set it up. All right, so my augmented matrix, my first row would be negative 27, 9, negative 3, 1, and negative 84. My second row, negative 1, 1, negative 1, 1, 0. Third row is 1, 1, 1, 1, 4. And last row is 8, 4, 2, 1, 6. Okay, let your calculator put it into reduced row echelon form. Take a minute and get that entered. All right, so this is what we end up with reduced row echelon form, which means what? What is the last column telling me? These are my numbers for what? A, B, C, and D, yes? So this is A, B, C, D. Okay, now go back to the original question. It said find this function, f of x equaling ax cubed. We now know what a is supposed to be, right? So we can dump those numbers into that equation. So the function that we're looking for, we said a was 2, so we have 2x cubed. We have negative 4 for b, so negative 4x squared. We don't have any c's. You can put in there plus 0x if you want, but it's not going to do anything. And then our constant is 6. Okay, so this function would fit all of the criteria they gave us. Does that make sense? Okay. We have one left. It says a ball is thrown straight upward. A position function S of t equaling 1/2 gt squared plus v sub 0 t plus s sub 0 can be used to describe the ball's height, S of t, in feet after t seconds. We've talked about quadratics before. All right, this is a typical picture. We toss a ball up in the air and gravity eventually pulls it back down. Yes? So we are given 3 different positions. We are told that after 1 second, that ball is 44 feet off the ground. After 2 seconds, it's 56 feet. After 3 seconds, it's 36 feet. It's already on its way back down. Okay? We can use those 3 points to set up a system of equations, just like we had in the last question where it said f of 1 equals this. All right? We can say f of 2 equals 44. When we put a 2 in for our time, we get a height of 44 feet. Okay? So it's the same kind of question, just given the information in a slightly different way. It says use the points labeled in the graph to find the values of g, v sub 0, and s sub 0. G is that gravitational constant. Okay? V sub 0 is your initial velocity. And S sub 0 is the initial height. Okay? So initial velocity, initial height, and the effect of gravity. That's what we're trying to figure out. So let's go back to our equation here. We have 1/2 g times t squared. We have v sub 0 times t, and we have s sub 0. Okay, giving us our height. So what we know is that if we put in, sorry, I just noticed here, this should be a 1. Put a 1 in, we get 44. So let's put a 1 in for our t values, and we are supposed to get an answer of 44. Okay? And then we have 2 more scenarios to dump in. This one says if we put a 2 in for time, we should get 56 for an answer. And our last one says if we put a 3 in for time, we should get 36 for an answer. Okay? Let's go ahead and set that up as a augmented matrix. So first row, 1 squared. 1 squared is 1 times the 1/2 in front. Gives us 0.5. 0.5 times g, right? G is the unknown we're trying to find. So my first number in my matrix is going to be 0.5. Then I have 1 times v sub 0, so 1. I have 1 s sub 0, right? There was no value for t that I was supposed to plug in there, so that's always just going to be a 1. And I'm supposed to get 44. Okay? Second row, 2 squared. 4, half of 4 is 2. This is 2 times v sub 0. We have 1 times s sub 0, and we are supposed to get 56. And our last row, 3 squared. 9, half of 9 is 4.5. We have 3 times v sub 0. We have 1 s sub 0, and we get 36. All right. So go ahead and enter that augmented matrix. Let your calculator do RREF. How big is our matrix going to be? A 3 by 4? Okay. All right, what did we have? 0.5, 1, 1, 44. All right. Does it look right? Okay. Quit out of that. We've already told our calculator to do our REF of A, so I can just hit enter again, and it will give me my new numbers. Okay. Now, what does this mean? All right, now go back and look at our variables. Our unknowns were G, V sub 0, and S sub 0, correct? So this is G, 60 would be my initial velocity, and 0 is my initial height, okay? So it started on the ground. Can we write our equation now? We have 1/2 G. Well, what's 1/2 of negative 32? Negative 16. So our equation is going to be S sub t equals negative 16 t squared. Our initial velocity was 60, so 60 times t. You can put the plus 0 in there if you want for S sub 0, or just leave it blank. Okay. Now, our next question says, find and interpret S of 3.75. What does that mean? We want to plug in 3.75 for t and find the height we're at, correct? Okay, so our equation was negative 16 times t squared plus 60 times t. All right, let's go ahead and use our calculator. We had negative 16 times 3.75 squared plus 60 times 3.75. What does it mean if we're getting 0 for an answer? It's back on the ground, yeah. So after 3.75 seconds, the ball is back on the ground. Does that fit our picture? Does it seem reasonable? Here's 4 seconds, 3.75. Seems reasonable? Okay. Last question says, find the time it takes for the ball to reach the maximum height. And what is the maximum height? Well, based on our picture, at 2 seconds, we are at 56 feet. Okay. Is that the highest point on my graph? Not quite. It looks like the ball's already started to come back down at that point. How do we find that vertex? How do we find the vertex for a parabola? Negative b over 2a is going to get me the x coordinate. Once we figure out that, we can find our y coordinate. Okay, so what was our equation? We had negative 16t squared plus 60t. So B is 60, okay? So x equals the opposite of that, so negative 60 over 2 times negative 16. What's negative 60 divided by negative 32? Okay. So it is telling us that the ball will reach its highest point after 1.875 seconds. Is that reasonable based on our picture? Yes, we already said at 2 seconds it was starting to come back down. Okay. Can we plug in 1.875 into our equation just like we plugged in the 3.375? Can we plug this in to figure out the height? Okay. So we've got negative 16 times 1.875 squared plus 60 times 1.875. Go ahead and calculate that. All right, you should be getting 56.25 feet. All right, so that's the highest the ball will ever go. Okay, so for homework, you guys are going to do 33, 35, 40, 41, 45, 46, 47, 48. Okay, the first two I want you to do by hand. I want you to try to get number 33 into RREF. Okay, use your row operations. Try to get it all the way down to RREF so you don't have to back substitute. For 35, just get it into REF by hand, row echelon form. Everything else you can do with the calculator. Okay, but the first two, I want you to practice those row operations.